Yes, the topic for today is the chapter 1 Chemistry of Representative Elements, which is part of the inorganic chemistry. And we will study the group trend today for the atomic radius. Talking about the group trend, a person should first be aware of what a group trend is. A trend itself says the regular variations, and a group means we are talking about the periodic table. So the regular variation that we see in the properties of the elements throughout the group is considered as the trend of that particular group. If the properties have a regularity, we say that there is a group trend, but if there is any irregularity or abnormal behavior from the regular behavior of the element from that particular group, then that is termed as the exception or anomalies. There are few exceptions in the groups. We will only stay focused on the representative elements, which is the S block and P block. Atomic radius. It is the distance between the nucleus of the atom to the outermost electronic shell or the valence energy level. As you can see that in this picture, we have two elements, that is lithium and sodium. Their atomic structures are drawn. The atomic number of lithium is 3, which means it has 3 protons and ultimately it has 3 electrons. Sodium, it is 11, which means it has 11 protons and eventually it will have 11 electrons if we are talking about the element. For lithium, you can see that there are two energy levels, 1s and 2s. But for sodium, we have three energy levels, which is 1s2, 2s2, 2p6 and 3s1. So as the atomic number is increasing, eventually it leads to increased number of electrons. Electrons are present in the energy level. You can also see electronic shell or orbitals. So the distance between the nucleus and the energy level increases as the number of electrons increases. And we know that as we move down the group, the atomic number will increase. So eventually the atomic radius will also increase. So how you can say it? That as we move down the group, atomic radius regularly increases. Why? Because the number of energy levels which are occupied by the electrons in which the electrons are revolving is increasing. This increased distance between the nucleus and the outermost electronic shell, eventually if the electronic shells are increasing, the distance between the nucleus and the outermost electronic shell will also increase. You can see that there is a table that is shown here which shows the P block 3, 4, 5, 6, 7 and 8 group. In all these groups you can see that there is a trend of regularity from boron, carbon, nitrogen, oxygen, fluorine and sodium. When we move down the group, the atomic radius of the specific element or the respective element is increasing. But as I have highlighted that in the group 3A of the P block, there is an exception. Exception means the group trend says that atomic radius is supposed to increase regularly. But for aluminium and gallium, you can see that the atomic radius is decreasing. For aluminium, it is 143 picometer and for gallium it becomes 135. It should have increased, but it is decreasing. It means it is an irregularity, and the remaining elements you can see that there is a regularity of the trend. So this irregularity is considered as the exception. If there is an exception, it means there will be a reason that is causing this irregularity. So now let's study the reason. This exceptions you get in the scientific reasons, and you can see that in the P block in group 3A for the boron family, there is an exception between the aluminium and gallium. Gallium has slightly smaller atomic radius than aluminium despite being located below in the group. Why is that? Because of the poor shielding effect caused by electrons of the d orbitals. What is a shielding effect? Shielding effect occurs when inner electrons fail to effectively block the positive charge of the nucleus from reaching the outer electrons, which leads to a stronger attraction between the nucleus and outer electrons that results in the smaller atomic radius. I have also mentioned the electronic configuration of aluminium and gallium. For aluminium, you can say that the valence orbital is p, and for gallium, it is also p. But in gallium, you can see that we have d orbital also involved. So these electrons present in the d orbitals are causing the poor shielding effects, which results in the decrease of the atomic radius. So this is the reason this poor shielding effect caused by the electrons of the d orbitals causes smaller atomic radius between aluminium and gallium despite it being located below in the group. So how you get this question in your examination is that mostly you get the question of 4 marks in inorganic chemistry in which you have to describe the group trend. And in that question you get a choice of the scientific reason in which they ask gallium has slightly smaller atomic radius than aluminium. So how you will answer it? You will simply write due to the poor shielding effect, and that shielding effect is caused by the electrons of the d orbitals. So all the exceptions that we will study further on, you get these in scientific reasons. Make sure whenever you are asked to discuss the group trend, exception must be mentioned. The group trend is regular throughout the groups, but if there is any irregularity, then that irregularity must be mentioned to get full marks in your examinations. I will also make a video on the Board of Inter-Education Karachi paper formatting for all the topics so that you have a better understanding of how you will get the question in your examination, what must be written, and how you will attempt it. Thank you so much. This is all for today.